When we're talking about a factor of a number, we're talking about two numbers that will multiply together to equal a number. So if we're talking about factors of 12 and 30, 12 and 30, if I look at just 12, my factors of 12 and 30, well, I know I can multiply, not 11, I can multiply 1 and 12 together, I can multiply 2 and 6 together, I can multiply 3 and 4 together. And those are going to be my factors of 12. When I look at 30 now, I can multiply 1 and 30 together. I can multiply 2 and 15, 3 and 10, and 5 and 6. So those would be the corresponding factors for each of my numbers, which is something we know and we can probably understand, we could come up with pretty quick. Finding the greatest common factor, all we have to do is look at our two different groups. So I'm looking at this group, and at the same time I'm looking at this group. And I want to find the greatest common factor between the two. So the number in there that is the greatest. And if I look, I do some looking, boop, 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 I see a 2 in both of them. Yep. A 3 in both of them. 4, 5. It looks like 3 would be our greatest common factor. But it's not. Because if we look even harder, we'll see I have a 6 in both of these situations. So 6 is going to be my greatest common factor between these two numbers, between 12 and between 3. So when we're finding the greatest common factor, all we're doing is finding the greatest number that I can take from both of my numbers. If I look here, it's the same thing when it comes down to a variable. So I've got the number 16p to the 4th, and I have 4p to the 3rd. So I can break that down into my coefficients and my variables. If I look, I'll have 16 and 4 are my coefficients. P to the 4th and p to the 3rd are my variables. My coefficients, if I look, my GCF, or my greatest common factor, is going to be a 4. These can both be divided by a 4 evenly. So my GCF is a 4. For my variables, I see they both have a factor of p. And really all I'm looking for is the one that has the least amount of p's. So my greatest common factor would be p to the 3rd. If I put those together to find the greatest common factor, I would have 4p to the 3rd. So what I'm looking at when I'm looking at coefficients and variables is I'm just looking what is the coefficient that's the greatest common factor, and then variables, what's the greatest common factor. So 9x and 36. Well, 9 and 36 both have a factor of 9. Since there is no x in my 36, then 9 is just my greatest common factor. 63 and 45b. I can look at 63 and 45 and try and find the greatest common factor. If I do a little bit of calculating, I'll see there 9 is also my greatest common factor. Since one has a variable and one doesn't, there is no common factor of b. If I look at 6 n to the 3rd and 3 n to the 5th, I can see my greatest common factor there is a 3. My variables, we both have at least an n third, so my greatest common factor would be a 3 n to the 3rd. For 6 r to the 5th and 6 r to the 4th, I can see they both have a greatest common factor of 6, and they both have at least r to the 4th. And then my last one over here would be 63x to the 12th and 35x to the 6th. So 63 and 35, let's see, common factors, 1 and 63, 9 and 7, 3 and 21, Interesting. Doesn't look like we're seeing anything there. 35, 5 and 6. Ooh, I'm sorry, 7. If I look at that, so 7 is my greatest common factor. They both can be divided by 7. I have x to the 12th and x to the 6th. My greatest common factor of my variables is x to the 6th. So that's what we do when we're finding our greatest common factor. Now factoring is where I take those same exact factors, I factor them out of an expression, and then I leave whatever is left. So if we look at this, for this one we said that 4p to the third was my greatest common factor. So I'm factoring out a 4p to the third. When I do this, I've got to incorporate, it's kind of the opposite of distributing. If I'm factoring out, I'm dividing these out. So 4p to the third is my greatest common factor in here. If I had 16p to the fourth, and I factor out a 4p to the third, we'll see here, 16 divided by 4 gives me a 4 left over. P to the fourth divided by p to the third, all I have in here is a p. If I do the same thing here, 4p to the third, and I take away 4p to the third, all I've got is 1. So my factored form would look like this. Now I can see that I can distribute real quickly, and I get my same answer. My greatest common factor here was a 9. If I factor out a 9, all I have left is an x. All I have left here is a positive 4. So you can see we could just work through these, and it's actually pretty simple. 63 and 45b, the only common factor I have there would be a 9. So I can factor out my 9. 63, if I divide it by 9, I have a 7 left. 45b, if I divide it by 9, I have a 5b left. That's my factored form. 6n to the third minus 3n squared. So I can factor out a 3n to the third. If I factor that out, 6n to the third, if I divide out 3n to the third, all I have left is a 2, because my n's cancel. My 3's will cancel on the next one, and all I have left is an n squared. At the bottom down here, I have a 6r to the fourth as my greatest common factor. On the inside, then, I have just a negative r left over, and I have a negative 1 left over. And then my bottom one, we said my greatest common factor was 7x to the 6th. So if I have 63 and I divide it by 7, I have 9 left. If I had 12 x's and I take away 6 of them, I have 6 left. 35 divided by 7 is going to give me a 5. And if I had 6 x's and I take 6 of them away, I have no x's left. My factored form looks like this. So when we're looking at this, just our general rule, when we're factoring something, we take whatever we can factor. So let's say if we have 10x and 5x squared. We take whatever they have in common. So here, with my coefficients, my greatest common factor would be a 5. So I factor a 5 out of those. If I factor, which means divide, because it's opposite of distribute. Distribute means multiply. Factor means divide. So if I divide 10 by 5, that leaves me with a 2 left over here. If I do 5 divided by 5, it leaves me with a 1 left over here. Now if I look at my variables, I've got x, and I have x squared. My greatest common factor between them is going to be my variable that has the least number present. So I have x, which means I have 1x, and I have x squared, which means I have x times x. So obviously I can see the smallest one I have is my x value, which is here. So if I divide x by x, I don't have any x's left. If I look at this side and I factored out an x, so one of my x's will cancel, that means my other x I still have to account for it. Last thing I do is I bring down my original plus sign. So I've got my factored coefficient and variable on the outside of the parentheses. I then have whatever is left over on the inside. And you can see, if you want to check yourself really quick, the opposite of factoring is to distribute. If I distribute 5x times 2, I get 10x, and 5x times x gives me 5x squared, which is exactly what I started with up here. So you can see that factoring is just the opposite of distributing.